An indexer is a special type of property that is in a class or a structure. It allows you to store multiple values in a single property. Now, normally when we have a property in a class or a structure, it only can store one value, but an indexer can store multiple values of a single data type. So in concept, it's similar to an array. And to define this within a class or a structure, you have to use regular property syntax, which means you have to define the private field, and then you have to use a public, and I'm not going to call it a field because instead of using the field name, you have to use a keyword this, but you have to do a public facing get and a set. So setting up the private field is very similar to setting up an array. Okay, you have to give it the data type in brackets. You give it the field name, whatever you're going to call it, set that equal to new, give it the data type, and then in the brackets, you give it the size. So very, very similar in concept to setting up an array. For the get and the set methods, um, you will use the keyword public, and then you're going to give it the data type. And then instead of using the same field name or property name, you have to use the keyword this. And instead of using a left and a right parenthesis, which we would normally use, we have to use brackets. And inside the brackets, we are receiving an integer. Okay, and so I'm just calling it integer I for index, because I'm going to use that number to index in to my indexer field. Okay, so in the get method, I need to index in and retrieve the value. Okay, so you can see here, return, I'm indexing into my names, which is a string array, and I'm returning the value. In the set, I also have to index into names, but I am placing the value in to the indexer. Okay, and this is how it has to be coded. Okay, you do have to use the keyword this, and you do need to use the brackets, and you have to receive that index value. So a couple key points that you need to remember when you are setting up indexers. The get and set accessors are always created using the keyword this. Okay, so the get and set accessors require the keyword this instead of the property or field name. The parameterized property is called an indexer. Indexers are implemented through the get and set accessors for the bracket operator. The ref and out parameter modifiers are not permitted. Okay, so we can't use ref or out with an indexer. The formal parameter list of an indexer corresponds to that of a method, and at least one parameter should be specified. That parameter is the integer. Okay, so it has to have an integer because you have to index in. Indexers are used on a group of elements. An indexer is identified by its signature, whereas a property is identified by its name. Right, so that is another key difference. And you'll see when we actually use an indexer in the main method, um, how that looks and how that is quite a bit different than when we're accessing a property. Indexers are accessed using indices, and properties are accessed by their name. And indexers can be overloaded, which means I could create several indexers using the, the field name names. As long as, I made another one an integer, I made one double, I made one bool, as long as they're different data types. So how do we use this thing? So this is going to be a very situational type use. So if you have a class or a structure and you need to store multiple values under a single property, uh, that is really the only time you are going to use this. So maybe teammates, if you have a team class, and you're going to store one of everything else, like the type of team, the location, but then you wanted team members, you would store multiple members. Or maybe if it was a family class and it's the same thing, their address, city, state, zip would all be the same, and then you would have the different names of the family members. So in this little example, I have my indexer class, which I am creating a object called team. So this is implementing this little indexer class that we just looked at. Okay, and so to put things into that private names field, I have to actually index into the object. So I index into my team object, and that is how I am assigning values. And so what C# does, if you start indexing into an object, which is not a normal way of handling objects, okay? If you start doing that, it is assuming that there is at least one indexer. So it'll come up here, it'll see the indexer, okay? And then it knows that when we index in with a 0, the first name in our list is going to be Mickey. And then it's going to add Minnie, Goofy, Pluto, Daisy. Okay, so that is how we place values into an indexer. To retrieve the values, it's kind of the same concept. You have to take your class object and you have to index into it. And then it will automatically go to that indexer and retrieve the values from that. Okay? And so when you're assigning values like we are, it's going to run through the set. And when you're retrieving values like we are here, then it's going through the get. And that index number is passed up here. And this little example is just a full programming example showing you how to use the indexer. So here we've got a size field, which I set to 5. And then we have our name indexer. And then we have a little constructor, which basically kind of zips through each of those elements in the indexer and assigns string empty because it is a string indexer. And then we've got the accessors, the public-facing accessors, the get and the set, where we are bringing in the index number. And in this case, I do have a little bit of error handling in here because we don't want them to index beyond the ends of our indexer. I am checking a range to make sure that the index is greater than or equal to 0 and that it is less than or equal to our size minus 1, because just like an array, we begin indexing with a 0. And then you can see as long as the index is in range, we can go ahead and index into names. And we can assign a temp variable, which we will then return to the main method. Now, if the index is out of range, what we're doing is we are just putting, making our temp variable empty. So it's not going to have anything in it. And then either way, that temp variable gets returned. For the set, we are again making sure that the index is in range. And we are only going to set the value if our index is within range, meaning it has to be between 0 and the size minus 1, which is 4. Because those are the only valid index values. And then here's the main method that is utilizing the class. And again, the class object is called team. And then I set a Boolean to false, and I get into a little loop where we're checking that Boolean. And then once we want to stop, the Boolean is set, it says, while we don't want to end, we're going to stay in here. And then once we want to end, we fall out of the loop. Okay. And so all we're doing in here is I've got a variable I create called sub. And as long as the sub is less than 1 or it is greater than 5, I have a problem. They have to re-enter it. And then below that, we're asking them for the name of the team member. And we are reading that in. And then any key to continue, Q to stop. And that is how we are filling it in. Once the thing gets filled in, then we are just looping through and displaying each item that is in that name indexer. Let's see, for this little example, I've got a family class, and above that, I define a constant size, which I set to 15. It's a global variable, which means that everyone knows about it. So that variable can be accessed by all. It's public, it's global, so any of the classes can use it. Then inside my family class, not only do I have an indexer, which I call family members, okay, I also have properties for address, city, and state. And you'll notice that for the family member indexer, it is being set to a size of 15. Okay, so basically we can store up to 15 family members with a single address, city, and state. For the constructor, the way that I initialize address, city, and state is pretty straightforward. For the indexer, we have a for loop we're looping through, and because this is a string, we are setting each element to string.empty. Okay. And then we have our get and set accessors for the indexer. Okay. And we've already looked at code for this. So this is very similar to the last example where we're basically making sure that that index number is valid. And if it is valid, we can retrieve the family member. If it is not valid, then we are sending them back basically an empty value. For the set, we are also making sure that the index is in range, and as long as it is in a valid range, we can place the value into the family member accessor. So then when we implement this one, I am creating Donald Duck's family. So the object here is duck. Okay, so we've got our family class, duck object equals new family, set my Boolean variable end to false. And so it's going to stay in this loop as long as it's not true. Okay, so as long as it's false, it'll stay in here. And so I've got a subscript I set to 0. And so if it's less than 1 or greater than size, greater than 15, it's going to come in here. It's going to say what family member do you want to enter. And then it's going to say enter 1 minus size. Okay, so maybe we should run this. So it's going to say 1 through 15. Size is 15. So that is what it'll display. And then as long as it can read that value in and convert it into an integer, okay, it's okay. If they miskey something, it's going to tell them to enter a value between 1 and 15. Okay, so by the time they get out of here, we are going to have a index value that is valid. It is a valid integer. And then enter the name of the family member. We're going to read that in from the console. And because we start indexing at 0, we're going to take that value that they enter and we're going to subtract 1 because we told them to enter 1 to 15. So if they enter number 1, we're actually going to store that in position 0. Okay, so we read that in, press any key to continue, Q to stop. So we read that in, and as long as they don't want to stop, we stay in this loop where we're entering the telling it which family member we want to enter. So we are picking our index number, and then we are entering the name and storing it. Okay, and again, so with an indexer like this, you have to index in to the object, which is completely different than how we add data to properties. So here we're indexing into the object. Now, once we're done entering all those family members, then we can fill in the rest of the properties. So what is the family street address? Okay, so here we're just taking the object dot address and we're storing it. What city do they live in? Again, it's the object dot city. What state? The object dot state, because these are all single values. Okay, and so you can kind of compare the difference between adding to an indexer versus adding to a property. And then once we have everything filled in, we're going to display the information back. And so we have to actually loop through the indexer. And because we were letting them pick the position where they were adding the values, some of the values may be empty. So when we are retrieving this, we are indexing in to our duck object. And as long as it is not equal to an empty string, then we can go ahead and print it out. Okay, because it could be when they filled this in, they chose to enter family member 1 member 10, and member 11. They don't have to go in sequence. So um, you certainly don't want to print out a bunch of empty family members. So that's why we have to check string.empty. And then we print out the address, city, state, just pretty much like normal here. Okay, and then you can see what that looks like when it runs.